video is going to cover Learning Target 2, Imaginary Solutions. It's our second learning target for our unit number 2 on quadratics. Our essential question today is, how do you solve a quadratic equation with imaginary solutions? To get into this idea of what an imaginary solution is, we need to consider the question below. What is wrong with this expression? Well, typically, you would want to go ahead and square root the 9. The thing that's wrong with this expression right now is the fact that there's a negative 9. So kind of thinking about this negative 9, remember, square rooting is to take the number back to the number that was squared to make it. If we think about 3 squared, you get a positive 9, because 3 times 3 is 9. If you take negative 3 and you square it, well, you still get positive 9, because a negative and negative is a positive. So there's really no possible way for you to even get this negative. So because that can possibly happen in math problems, there must be a way to deal with this. Since there's no number that can make the negative 9 that you'd have to square root, there's no answer here. Go ahead, try putting it into a calculator. Try doing the square root of negative 9. Your calculator is going to give you an error. So how do we deal when this happens in our math problems? The way we deal with it is actually by talking about a new kind of number. It's called the imaginary number. Much in the same way that pi is a symbol and a letter that means a certain number. Pi is 3.14. I is the number square root negative 1, which in reality, it doesn't actually exist. You can't find it in nature. Okay? It is not something that we can compute, but it happens regardless in our mathematics. So we have a letter that represents it. Just like pi represents 3.14, I represents square root negative 1. What is a complex number? A complex number is a number that has a real part being added or subtracted to an imaginary part. The a is what we call a real number, such as 1, 2, negative 5, a half, any of those real numbers. But the bi, it's what we call the imaginary number, an imaginary part. Together, they make a complex number. Now, it is possible to write real numbers as complex numbers also, but more often than not, you'll be dealing with real numbers added and subtracted to imaginary numbers as we continue this learning target. Let's get used to working with I. Let's think about the square root of negative 4. Where does the negative 4 come from? Well, the negative 4 comes from the square root of 4 times negative 1. Now, if we had a 4 being square rooted, we would end up with a 2. But then we still have a negative 1 underneath the radical sign. Since we want to express this with an imaginary number, we are just going to replace this part right here, the square root negative 1, replace it with an I. So our answer is 2i. So if the square root of 4 is just 2, the square root of negative 4 is 2i, imaginary. What about the 13? 13 comes from 13 times negative 1. In this situation, we actually cannot compute the square root of 13 as a whole number. That square root of 13 would be a decimal that would repeat for a really long time. So instead of writing out some kind of rounded answer, we can still write in our answer a square root 13. But this negative 1 part is the I. So the square root of negative 1 we're going to write here in front as I. Okay, a big heads up. Okay, big heads up right now. Most students mess up when they start thinking that I is -1. Okay, this is not the case. Okay, this is not true. I is the square root of -1. This is true. So don't confuse -1 with square root -1. I is not and is never a -1. I is a square root of -1. So now let's get into what this is really useful for, because we've been solving quadratics. We've learned how to factor, complete the square, but we've also learned quadratic formula. In every case, we've always come out with actual numbers, real numbers. But let's try using the quadratic formula on this quadratic right here. In this quadratic, our A is 4, our B is also 4, and our C is equal to 10. Let's put those into the quadratic formula. So negative B would be 4 plus or minus the square root of 4 squared minus 4 times A, 4, times C, 10. All divided by 2 times A, 4. Let's start to simplify this. We end up with -4 plus or minus the square root. 4 squared is 16 minus 4 times 4 is 16 times 10 is 160. All divided by 8. Simplify this one step further and we end up with a square root -144 divided by 8. And see how in this problem we end up with a negative number underneath the square root sign. Type in square root -144 and you're going to get an error in your calculator. So instead we are going to turn this into its imaginary form using I to represent this negative. So if the square root of 144 is 12, then the square root of -144 would be 12i. So that's the difference right there, okay? That I, that's the difference in our problems going forward. Since we end up with a -4, a 12, and an 8, all these are reducible by 4. So let's reduce it down by 4. -4 divided by 4 is 1. 12 divided by 4 is 3. Don't forget the I. And 8 divided by 4 is 2. This is our answer. And it is two answers as we get with many quadratics because of the plus and minus sign. So one answer is -1 plus 3i divided by 2. The other answer is -1 minus 3i divided by 2. So still two answers. The only change is we need to make sure that we are having an I in our answer because we were square rooting a negative number. I think we should try this one more time to kind of get used to the way that I pops up in problems and what to do about it. So we're going to solve the quadratic 7x squared minus 5x plus 12 equals 0. A in this problem is 7. B is -5. And C is 12. Plug these values into the quadratic formula and I get -5. Remember, the negative in the formula, the 5 brings its own negative sign. Plus or minus the square root of -5 squared minus 4 times A, C, all divided by 2A. Let's simplify the pieces that we have. 2 negatives on the 5 make a positive 5. 5 squared is 25. And 4 times 7 times 12, which would be 336. All divided by 14. subtract underneath the square root sign, and I get 5 plus or minus the square root of 25 minus 336, which is a negative 311. 14 is still on the bottom. Now negative 311. 311 is not a perfect square. 311 is also prime. We can't break down 311 either. We're not going to square root it as well. But we do have a negative here, so we do want to take care of the fact that it says negative 311. Remember that the square root of a negative will give us an imaginary number. So when I write my final answer in this problem, I want to bring the I outside of the square root sign, and he's basically holding on to the negative for this 311. It's still all over 14. 5, 14, and only an I can't get inside of here, and only an I are not reducible like the last problem. So I am done at this step. Remember, if you are doing a quadratic formula and you end up with a negative underneath the square root sign, your answer must use an I to represent that imaginary number. Okay, that covers how imaginary numbers pop up when we're solving quadratics. We still use a quadratic formula, so if you haven't memorized that yet, please do so. If you have questions about anything in the notes, please make sure you write them down in the left-hand column. And also don't forget to hit the continue button, submit your answers, and hit submit so that your video views get recorded.